Hello, it's nice to be with you all. I know you're here to listen a little bit about science, but I wanted first to show you a miracle. I have it here in my pocket. Nowhere else in the universe do we know that that's possible. For almost all of Earth's history, about 80% of it, it would be impossible. It's not possible on the Moon or Venus or Mars, nowhere else. And Earth has made possible this access to instant energy that we use every day when we breathe and eat, and process energy in our bodies that is made possible by 4.5 billion years of planetary evolution. So what I'd like to do today is not talk too much about my own particular scientific interests or results, but rather to tell you a story, the story of the Earth, and how gradually exploring this story and teaching it to many undergraduates over many years has come to make me ask questions about what it means to be a human being and what might be the role of human beings in the grand process of planetary evolution that has taken place over the last 4.5 billion years. Now these questions of what it means to be human have been with us forever. So this is an ancient Chinese painting. There's a man looking at nature, feeling the beauty and wonder of it, feeling himself standing in nature and wondering what it might all mean and whether there is a meaning to his life relating to this world. Now that was 400 or 500 years ago in China, and his descendants might not be having the same experience. We've become so numerous and so isolated from the world that we don't experience these questions as directly as we once did. Not true only in China, but also perhaps in Belgium. I'm not sure if, when you're stuck in traffic jams, if you're really pondering the beauty of the Earth and the meaning of your life. I certainly am not. So I'd like to try to think about the Earth from a sort of a universal perspective. As scientists, we try to understand the laws of how things work. So on Earth, we study the laws of physics, we study the laws of chemistry, and we look up at the stars and we see, oh, they're the same elements in those stars as there are in our sun. These are universal processes that we can study here on Earth and know what's happening in the universe as a whole. Well, maybe when we study Earth history, we're also studying laws of planetary evolution, and how planets evolve, if they're fortunate, to give rise to life and ultimately perhaps to intelligent civilizations. And so when we look at human beings in that context, there's the question of, does it give us answers or make us ask questions about, give us insights into questions that we might have had, particularly when we were younger, and that we generally largely avoid? Might there be a purpose and meaning to human life? Is it only because we're following the laws of evolution, survival of the fittest, we have to compete, put down the other guy, kill them, succeed, pass on my genes to the next generation? Or might there actually be a purpose to human civilization, to intelligent civilization, in a process of planetary evolution that takes place over billions of years? So I've tried to put some of this in French on these slides. Please forgive me if I've made mistakes. So the Earth begins like the Moon. It begins as a piece of dead rock. And that piece of dead rock is hot. And so it melts, it divides into different layers, it forms the Earth crust, it forms the Earth's core, oceans appear on the surface, there's an atmosphere. And the interactions among these layers over the first tens of millions of years of Earth history create a stable climate. Remarkably, the climate has been stable on Earth for about 4.4 billion years. Stable meaning liquid water. Then, over the next several hundred million years, life begins. And then, over the next billions of years, life gradually transforms the planet. And through its interactions with the planet, life also evolves to become ever more complex, ever more large in size, and with relationships of ever-increasing scale, and with greater and greater access to energy from the sun, from our star. And then, in the last blink of a planetary eye, the last instant, there's been this appearance of not only people, but human civilization. So that's a moment in the evolution of the planet. What might it mean in the context of the planetary history taken over that long period of time? So at the beginning, the Earth's surface was like the moon. The moon is a planetary fossil. It has differed from the moon in that it had an atmosphere. There was no oxygen at all. There was no life at all on the surface. That was 4.4 billion years ago when the moon was formed. And today, life is everywhere. It's on our skin and our digestive system. Everywhere we look as we walk outside, if we're not in a building like this one, but even here we see life as we see each other. But outside we see the life of the world. It's everywhere. Every nook and cranny filled with life at various scales and of various sizes. So what happened? What happened that made this incredible planetary transformation over this long period of time? So the appearance of life, of course, is one of the great unknown scientific questions that scientists in many fields are looking at and addressing. It appears that we know it requires three things. You have to have rocks, you have to have water, and you have to have the energy from the sun. In my view, given a stable climate and liquid water, life is what planets do. It's a natural planetary process that will occur throughout the universe given the appropriate raw materials. And enough time. So on Earth, we think it may have taken about 700 million years. Think about it. 700 million years. Imagine if you could play the lottery 1,000,000 times. You're going to win once. And so life gets to play the lottery over and over again, trying to develop the processes of living systems. And it only has to succeed once in that long period of time for life to be able to gain a foothold. And once life is able to reproduce, then it can evolve through natural selection over the subsequent period of Earth history. So life begins, and the life and the planet co-evolve together, and they evolve together in a series of steps. And each one of these steps involves increasing scale of relationship and also increasing access to energy. At the beginning, there are these simplest of cells called prokaryotes. You'll see that they have no nucleus. They're extremely tiny. They just have strands of DNA in the middle of them. They divide about every 20 minutes, and they often, most often, survive and thrive in the absence of oxygen, which we call anaerobic. So the first life had a very difficult time because there was nothing for it to eat, and so it had to eat the products that were actually formed by the Earth. Those products are very low in abundance, and so life would have established a foothold, but have been very meager. Then a revolution happened, and life began to be able to make its own food. So it would use the chemical systems of the Earth to be able to make sugar, glucose. There was no photosynthesis as yet, there was no formation of oxygen, but there was the possibility of life beginning to thrive and become a little bit more abundant and occupy more ecological niches within the planetary system. And this stage lasted about 500 million years. No oxygen still on Earth's surface. Then, through a complex series of processes, and it's not understood how these complex processes necessarily came about, but again, there is the magic of time, life discovered photosynthesis. Prior to photosynthesis, using carbon dioxide and water, life was having to use elements like hydrogen and sulfur to survive. But with the advent of photosynthesis, they could take two very abundant molecules, carbon dioxide everywhere in the atmosphere, water everywhere, energy from the sun, and through photosynthesis, you make food. So this allows the possibility of suddenly not being limited by resources, and life could thrive and bloom, grow magically and grow substantially in abundance on the Earth's surface, and get killed because it made a terrible poison, oxygen. So all of us were probably told by our mothers that you have to eat broccoli and blueberries because they're full of antioxidants. So oxygen is gradually killing us. It gradually kills all our cells. And all of our cells react with oxygen and get destroyed back to carbon dioxide and water. So we have developed protection against oxygen. We can breathe it and not die. But early life would not have had that protection. And so there was this balance. On the one hand, photosynthesis was amazing and allowed them to use these abundant ingredients, water and CO2. And on the other hand, it produced this terrible pollutant, oxygen molecules. So in order for life to thrive, it was going to be necessary for it to develop protection against oxygen. And we can imagine how that would arise through natural selection. If you had a mutation that gave some oxygen protection, then you would be able to be more abundant in life, you would be more successful. And this kind of protection in the development of oxygen took several hundred million years. And then life made an amazing discovery. It discovered that it could make use of the oxygen. No longer was it only a poison, but it also allowed access to 18 times more energy. So up here on the top, you see the anaerobic mechanism of metabolizing glucose. And that little box on the right-hand side is the 2 ATPs, the energy molecule for biology. And that's the amount of energy you get from one glucose molecule in the absence of oxygen. But if you respire using oxygen, you get 36 units, 18 times more energy. So you can imagine a race. You have a car with 10 horsepower. It's using the gas. It gets 10 horsepower out of it. You have another car that suddenly it has 360 horsepower. Who wins the race? So this ability to metabolize using oxygen gas creates a great advantage for life and allows different forms of life to occur. Now, this respiration using oxygen requires that there be oxygen around. And all the rocks of the earth absorb oxygen. The ocean absorbs oxygen. So life can make the oxygen, it's creating a source of it, and then the earth is a huge sink for oxygen. So oxygen can't build up because the earth is gobbling it up. Gradually, the earth rusts. So the black rocks coming out of the earth, the volcanic rocks I like to study, they're black and beautiful. You expose them to the oxygen in the atmosphere, they turn red. And so the whole surface of the earth gets rusted. It absorbs the oxygen coming out. It gets saturated with oxygen at the surface, and then gradually oxygen can rise in the atmosphere. But only through this long process of saturating the surface with this very reactive molecule. So, once this happens, then Earth acquires the possibility of having life that breathes. And this life is an entirely different form of life than the early, very simple molecules. Now we have cells that we recognize. They have all these little organelles in them. They have a nucleus. They're 1,000 times higher, larger. So on the lower left up there, you see the small prokaryotic cells. They still exist. They're within us, all around us, on our surface of our skins and our digestive tract. And you have the large eukaryotic cells 1,000 times larger. They are aerobic. They require oxygen. So they can only appear on the Earth once you have the oxygen available for them to use. And they can use 18 times as much energy as the little tiny cells. All of this is still microbial. So throughout all of this period of Earth history, more than 3 billion years, Earth's life is scum. Okay, you see in a pond, you see these little cells covering the pond in their communities. That would have been Earth for most of its history. So these processes permit more and more energy from the sun. You're having more and more photosynthesis, which is receiving energy from the sun, which is creating oxygen and also organic molecules. So it's going to be taking the energy from the sun and storing it. And it stores it in things like the match that I was just showing you. And the oxygen is here in the atmosphere. We're sort of creating a kind of fuel cell where we have one molecule that wants to burn. If it's in the presence of oxygen, you bring them together and you get instant energy. That's what happens to living creatures. That's what we're doing all the time. And this is all the product of Earth having absorbed and stored energy from the sun over billions of years. So, we have these two worlds of life. We have the little prokaryotes, and then you have these big eukaryotic engines, big meaning you can see them clearly under a microscope. And within those eukaryotic cells, you see these little tiny organelles. That's the little dark things. And those are thought to be prokaryotes that are now enclosed within the eukaryotic system. So they have their own DNA. So this means that these eukaryotic cells are actually a kind of evolving partnership between the very small cells in the lower left. They begin to work together, they form partnerships, they generate symbioses, and gradually you create something that's completely independent in a larger scale with a much larger scale of relationship and a much greater access to energy. So the prokaryotes form their colonies, their symbioses, they become permanent, and you make the eukaryotes. So the evolution of the planet seems to be this process where we take energy from the sun, we create life, the life creates the possibility of getting even more energy from the sun and using more energy, life gets bigger, the planet stores more energy over time. This is a process of energizing the planet and creating ever more complex forms of life. So I thought I'd show you this world. Do you see my mouse? Where is it? Upper left, lower right?
Left here. Something.
Oh, there it is. I see it. Oops. Okay. So in the next few minutes, you're going to see this microbial world. This is one of the eukaryotic cells. You can see all the little different organelles within it. And when you look at the blue in the background, you see little bits of shimmering things. Those are the bacteria. Those are the prokaryotes. They're too small to see, but they're there. These are the eukaryotic cells, paramecium, and they're going around eating the bacteria. They're also having relationships with one another. So they have friends. They're deciding who to mate with. They're cooperating and not destroying each other. They decide to get together. They make babies. They divide. Sometimes when they get together, they actually share their DNA. They actually join and become joined together, in which they can share their DNA. Here you can see that happening. They have relationships with one another. Life is good. Except that there are other creatures also down there, and the other creatures are not sort of plant-eating. Oh, this is the scale that we're looking at, so that's the eye of a needle. So you can see the paramecium flying, swimming around in the eye of the needle. You can't really see the bacteria, they're too small. This is a eukaryotic cell that's developed a little tail, and so it sweeps the bacteria into its mouth. Everybody likes to eat. This is a vorticella. It has these little whiskers that it's using to suck the bacteria into itself so it can eat them. And then you have this guy, also a eukaryotic cell, but he's not nice. He swims around and whoops, goodbye paramecium. So we have carnivores. We have the carnivores and the herbivores, and gradually some of these create these partnerships, and then you can form a first multicellular organism, still very small, you can only see it in a microscope, and that little pulsing you see is the heart. That's the initial heart of this being. Now, the eukaryotic cells also join together and make partnerships. So these are eukaryotic cells, not bacteria, and they form something called volvox, which is about 50,000 of these eukaryotic cells in partnership and forming specific functions that allow them to survive better within their environment. So the eukaryotic cells also form partnerships. And ultimately, they form partnerships that are big enough that you can make visible life. So this is one of the earliest forms of visible life occurring about 550 million years ago. This is a trilobite. And this is now, we're up to only the last 12% of Earth history. And this is the eukaryotic cells forming partnerships to make something made up of hundreds of thousands of them. And those hundreds of thousands of cells then work as an individual unit, and they can absorb oxygen from the surrounding and breathe. So once these cells form, they get progressively bigger through time. So on the vertical axis, you have the number of cell types within a multicellular organism, and on the lower horizontal axis, you have time. And so you have the first primitive cells, billions of years. 500 million years ago, you get the first primitive multicellular life. It gets bigger and bigger and more complex until you get mammals, redwood trees, blue whales, all existing in the modern era. So we see this planetary evolution. We start with almost no capacity to absorb energy from the sun. The sunlight just reflected off the surface. The surface has no life. It has no oxygen. It becomes habitable only for the most primitive of microbes. And today, we have a system in which oxygen and molecules, reduced molecules like plants that we eat, and fossil fuels, make possible instant energy and give us access to a power that is unparalleled in the context of earlier planetary history. And instead of having little tiny ecosystems that occur in the eye of a needle, now we have even global ecosystems on a vastly greater scale than has been possible previously in Earth history. So life is a planetary process. It evolves in conjunction with the planet. It has to transform the planetary surface. It modifies the surface to make it more habitable. There are long periods, hundreds of millions of years, in which there's almost no change. And then suddenly there's a big change in access to energy and scale of relationship. So evolution of planets appears to occur by having ever more and more access to energy and ever greater scale of relationship and ability to communicate and have complex systems. It's like a staircase. You go through these various steps as a planet. And in these various steps, it's not assured that a planet will move to the next step. Maybe Venus had the first primitive cells, but it was too close to the sun and too hot. It didn't make it. Maybe Mars evolved a little bit further along on that chain, maybe to the second step. But Mars is too small. It couldn't hold on to its water in its atmosphere, and it's too far from the sun, so it's too cold. So it only makes it to the second step. And Earth has gone through all these steps up to mammals appearing about 200 million years ago and human civilization appearing like that in the last instant of planetary history. Okay, so you can probably intuit that we're going to move on to a perspective of human life from this overall view of how planets exist. So, the first thing is that life and planet are inextricably linked. They co-evolve together. All the systems of the Earth are linked to one another, and all of life is dependent on these systems. Life is planetary. We are planetary beings. We're not like Star Trek, where I guess Star Trek is the wrong generation. We're not like Star Wars, where suddenly you go on a spaceship and you land on another planet and you go to a bar and have a drink. Okay? Earth has evolved 4.5 billion years to be absolutely perfect for us. We are Earth beings. We are planetary. And we're partnerships. So I know all of us think we're very important, but really we're just a community of about 1 billion, it's actually 1 trillion, about 1 trillion eukaryotic cells. Every part of us, our skin, our eyes, our heart, our kidneys, our pancreas, our brain, everything is these eukaryotic cells that have formed partnerships. And we have our microbiome, probably about 10 times more cells than the eukaryotic cells. And on our skin, 10,000 of them on every square centimeter, in our mouth, our digestive system, everywhere. So we are this community of trillions of cells. Think of the scales of interactions. And we are exquisite instruments. We do things that no computer can do. We have feelings. We have intuitions. We have thoughts. We have the ability to see, to hear, to sense, all at the same time. It's not just bits of information. We are truly instruments, planetary instruments. And we use energy. So when we eat our food, we get energy equivalent to 100 watts, a light bulb. So it's amazing, isn't it? We eat a little bit of food, we generate 100 watts. If we're cold at night, we snuggle up next to our partner, we're each 100 watts, so we warm each other up. It's great. That's the amount of energy that we're able to use for running marathons, for riding in the Tour de France, for thinking, for everything. And yet, as human beings in the modern world, if you're in Europe or in America, you're using more like 10,000 watts. 100 watts, 100 times more energy than we get from food. It makes us supermen. We can fly through the air. We can go faster than a speeding bullet. We can see through walls. We can leap buildings with a single bound. We can use machines that are able to create and remove mountains. We are supermen because of this access to energy. And the average access to energy for the average human being on the planet is about 2,500 watts. That's 25 times what we get from food. And for the powerful nations, they use ever more and more energy. And so energy is power. The more energy we have access to, the more we're able to dominate the world and dominate the environment. And this is the largest energy revolution in all of Earth history. The transition from anaerobic to aerobic restoration was a factor of 18. The transition from food to accessing fossil fuels, wind, solar, that humans are able to do is a factor of 100. And in focused ways, it's far more than that. So this is the greatest energy change in 4.5 billion years. Now, it's possible because Earth stored up treasure in the form of fossil fuels. So on the top diagram, you have time on the lower axis, and it's over about 400 million years. And that gradually rising gray curve is the fossil fuels that are stored in the Earth over that 400 million years. And then we come along, and that red arrow on the right shows what happens to fossil fuels in a few centuries of human use. 400 million years of storage, 3 centuries of destruction. Earth makes fossil fuels at the rate of 1 gas station. 1 gas station. So it's just, it seems so trivial. But if you pump at 1 gas station for 400 million years, you get a lot of fuel. So this to me is not necessarily a bad thing. This is, at the bottom, I have the last, a scale of 10,000 years, and you go 5 or 10,000 years ago, we're not using fossil fuels, then you have a few centuries where we use them all up. This allows the transformation to a technological society. It's as if Earth stores this energy for intelligent life to use, and then intelligent life has one chance to use this energy to develop technologies that mean they don't need to use fossil fuels anymore and can directly access energy from the sun or from nuclear fuels. It gives the possibility of a planetary evolution by having this long storage over the hundreds of millions of years. Just like in some organisms, you have an egg, and it has a certain amount of energy within it, and that energy is all used up in order to be able to make the chicken. So in the same way, the Earth may have stored all this energy in order for intelligent life to be able to make use of it. So, biggest energy revolution in all of Earth history in the last century. How about revolution in terms of scale of relationships? Language. We can communicate to each other through language. We can pass knowledge from one generation to the next through books. We have this possibility of printing things and sending them all over the world. That was hundreds of years ago, and now we have global communication, and through our cell phones that most of you turned yours off, it was great, we can communicate with billions of people all over the planet instantaneously. We have the capacity to relate to scales much larger than ourselves. We can study the heavens, we can learn about the Big Bang, we can understand that there's 200 billion galaxies in the universe, we can feel small and relate to this huge world, and we can go down to the smaller world and understand the cellular world and the world of DNA and microbes and atoms. We can relate to this scale that's much smaller than ourselves. This is a complete transformation of relationship. It's not just one animal talking to another animal. It's also being able to relate to the scales of the universe and scales much smaller than ourselves. For the first time, we have the possibility of directed evolution. We don't just rely on natural selection and random mutations. We can actually change things. We have the possibility of a new frontier, which is probably going to come in the lifetimes of the younger people in the room, where there's this combination of biology and technology. And we have a sensibility for the universe. We can feel the immensity of the universe and marvel at the possibility that we, as these small organisms, can be aware of this whole unimaginably greater than ourselves. We also have the possibility of planetary sensing. So there's thermometers everywhere, there's seismometers looking at the Earth's interior, there's measurements being made all the time, and we have these satellites that are looking at the Earth, thousands of them now, circling over the Earth, taking remote sensing measurements, telling us about the temperature of the oceans, where is methane being sent out. We're becoming a planetary sensory apparatus as a community. So if you look at these things, you look at the energy transformation, you look at the relationship transformation, they're the biggest that's ever happened in 4.5 billion years. And people talk about the Anthropocene. That's one of these little tiny geological epochs where you're finding a change. And when did it start? Did it start with the atom bomb? What's the date? Is there really going to be a record of it in the sediments? The geologists argue about this. But if you look at it from the perspective that I'm giving you of this difference of relationship and energy, it's an entire new planetary function. We have a revolution in energy equivalent greater than the revolutions in the past. We have a mass extinction going on. We have extraordinary changes to the environment. We can manipulate DNA to control evolution. We have a revolution for humanity and its interactions with the world and the potential to understand the universe. It's the biggest change in all of Earth history, and it's happening now, right now. It is potentially, if we were able to survive, the largest change in all of Earth history. Not an epoch, but moving to one of these great changes in Earth history, like an era or an eon. So, the perspective from the history of the Earth, viewed from the ways that I've been describing, is that human civilization is an entirely new step in the functioning of the planet. So, I think there's a lot of intelligent life probably out there in the world, and they go around checking up on the planet. So, they come to Earth every million years to see how's it going. And they came 1 million years ago, and they saw, oh, it's, nice planets, lots of life, develop of aerobic metabolism, interesting, very good. And they come back today, and they look down at the planet, and they go, oh my God, that planet just woke up. It suddenly has people we can communicate with. It suddenly has members of the universe that could become a part of this great universal experiment of a living universe. Wait a minute. What? They destroy their planet? They kill each other? What are they? Insane? So, in each interval, planets can evolve or not evolve. And if a planet evolves, it moves to a new level of functioning. If it doesn't evolve, it goes down. And I think because of what I described with fossil fuels, you get one chance. I don't think you can say, oh, we're no good. Let us go away. We become extinct, and then in 50 million years from now, there'll be another form of life. No, the Earth's treasure chest has been used up. The possibility is no longer there. Evolution of the planet is not assured. It depends on something. So Earth is at an instant in which there is a species with exceptional capacities to give completely different properties to a planet that would be visible, say, to visitors from outer space who look down at us. And the evolution of the planet then depends, whether we pass through this next stage, it depends on our behavior. Now, if we destroy the planet, it's not going to happen this century, but you can see how it might happen gradually over 1,000 years or so. Let's say our civilization lasted for 10,000 years. That would be a long time. But 10,000 years is nothing compared to 4.5 billion years of Earth history. So if civilizations only last for 10,000 years, they're like fireflies in the universe. You see one go boop, boop, boop. They just appear and disappear. They don't last. The only way there can be life elsewhere in the universe is if there's a civilization that lasts potentially for 1 million years or more. Imagine the understanding that they would have relative to us. We are universal cavemen. And the only way they can have survived that long is if they have allowed their planet to thrive in their presence. Therefore, they would have an appreciation for life and an appreciation for their planet. Otherwise, they would simply destroy themselves and their planetary systems. The planet would not evolve. So we don't need to worry about them coming to eat us. Okay? They're benign. If they're out there, they have developed a sensibility and appreciation of life and the universe that makes them, if anything, want to help us rather than to destroy us. So, human civilization is this entirely new step. Are we going to make it to the next stage of planetary evolution or not? So, what do we bring? What potentially do we bring? We can be aware of the Earth and its systems. We can be aware of our surroundings, where we come from. We have the ability to communicate with others. We have the intelligence potentially to take care of things and try to do our best. So we are an instrument of planetary consciousness. The planet without us is not conscious of itself and has no ability to communicate with others in the universe. It has no self-awareness. But we bring that capacity to the planet. We are the development of an entirely new organ of perception in the planetary system, an organ of consciousness which applies to the planetary systems. Okay, but instead we're not like that. We're more like a planetary cancer. We use the planet for our own benefits. We don't realize we're a part of something that's been evolving over 4.5 billion years. We think it's all out for me first, and, me first. And we create these environmental problems, and it's not just global warming. We're destroying much of the biosphere. This is cutting trees in Oregon. This is Nebraska cornfields. We take over the prairies so full of life and we turn them into monocrops. We destroy the soils. The lower figures there, one of those curves is the rate at which soil is formed naturally by the earth, and the other is the rates at which soil is destroyed by erosion under natural systems. And then that dark thing up at the top shows the rate of soil erosion by modern agriculture. Orders of magnitude larger destruction of soils. So if you look at the amount of soil in the Great Plains of the United States that was there in 1700, and you look at the amount of soil that's left in the Great Plains today, it's greatly reduced. So it's not a matter of something happening in the next decade, but over hundreds of years, the destruction of these soils will lead to great famine, potentially, for human civilization. We, of course, modify the composition of the atmosphere. We change the course of rivers. We fish out the oceans. And it's not just fishing out the oceans. Because there are fewer fish in the oceans, there's seabird populations are greatly declining. We have groundwater depletion. This is one of the most important agricultural regions in India. And those red colors are the decline in the water table. Groundwater is essential for irrigation in this region. And of course, we have mass extinctions. And these are animals that used to be in North America before people arrived. People arrived and knocked them out. We see what's happening with insects, with butterflies, with amphibians. All over the world, we see this incredible destruction of life. And we continue to grow in population, and every new person under the way that we live today is an agent of planetary destruction. So, planetary destruction as we live is a product of population times prosperity. The more prosperity we have, the more food we eat, the more meat we eat, the more resources we use, the more land we destroy for our own personal use. So every quarter, we see results for the GDP. economic miracle. The GDP has grown. And if GDP were to decline, the government would be thrown out of office. We want infinite growth. Maybe what we also need at the same time is a planetary destruction index, reported every quarter. So we look at the state of soil erosion, at groundwater depletion, at the fish population in the oceans, at the land converted to agriculture and destruction and construction. We look at biodiversity. We look at the increase of CO2 in the atmosphere, the acidity of the oceans, the growth of human population, the global temperature. All of these get worse every year. So it's a different view of sustainability. Sustainability means you have to be able to live without having an increase in planetary destruction. And that's planetary cancer. We don't care about the whole of the planet. We don't care about destroying it. Look out for number one, me first, America first, my country first. What matters most is my economic well-being. I don't think in America that the administration necessarily doesn't think global warming is happening. They just say economic well-being is more important. I'm not going to let it influence that. And what economy growing is the most important thing. All the planetary resources are here for my benefit, the ore, the oil. If other species are in the way, kill them. Or if they taste good, eat them. Even if I'm aware that I'm part of a larger whole, it's an annoyance. It infringes on my appetites or personal desires. What's in it for me to save this other life? What's in it for me? Me first. So human civilization and each one of us brings these qualities to the planet as a whole. And we are potentially organs of planetary consciousness. We're here. We can sense ourselves and understand. We can be aware that we live in a larger context and communicate this with others. We can try to be aware of the consequences of our actions and act for the good. I have choices every moment of every day in this respect. Instead of, what's in it for me? What can I do to help? You're in your apartment and you're cleaning it up, and a friend comes over and they say, hey, what can I do to help? They become a good friend, and then you want to go and help them clean up their apartment. If they come to your apartment and they say, good luck, buddy, there's nothing in it for me, enjoy, once it's clean, invite me over for dinner, do we think that's a good person? So in all of us, in all our stories, in all our life, we've heard stories of heroes. We love heroes. We respect them. And heroes sacrifice themselves for a greater good. That to me is almost a definition of heroism. Okay, I'm not a I was raised Christian, but I'm not really a Christian. Don't go to church or anything. But I look at Jesus, and he didn't, say, hey man, I'm not going in there, they might crucify me. No. I'm going to stay out here and have everybody adore me and think I'm a god. No, he goes into town, he carries the cross, he wears the cross of thorns, he's crucified. He's a very intelligent man. He could have avoided that. But he accepted that in order to be able to do something to try to help humanity. And I think that all the great spiritual traditions provide messages like that, of guiding us not only how to live, but how to live in a way that would save the planet. So I know this is a difficult subject. Sustainability requires that planetary destruction does not increase, and all those things in yellow relate to food. 2/3 of agricultural land is used for animal production. 2/3. So if the world stopped eating meat and ate plant-based foods, 2/3 of agricultural land could be returned to its natural state. The oceans would thrive, the forests would grow, there would be more habitat, there would be much less global warming because no more methane and CO2 coming from food production. So when everybody says, oh no, it's global warming, what are we going to do about global warming? No, global warming is the last thing on that list. It's all those other things that are so important. And all those other things relate in part to our personal habits. Even if we became half plant-based, that creates a huge change for Earth systems. So the root problem, I think, is that I do not realize I am a planetary being. I am part of the planet, not a user of the planet. We're part of a process of planetary evolution, and we have the possibility of bringing this entirely new capacity to the Earth. We're completely dependent on planetary systems. Why would we destroy them? Why wouldn't we want to understand them better so that we could sustain them? And this leads to what I think is the most dangerous pollutant, and the most dangerous pollutant is human egotism, the pollutant of what's in it for me. I pollute the world moment by moment in attitude and action, and if we were to change from that attitude of what's in it for me to what can I do to help, this would be a transformation of the world. These are not societal problems. Of course, there are issues that have to be done by governments with infrastructure and so on. But these are individual problems. I was saying earlier today, I was talking to a reporter, and they asked me my opinion of Donald Trump. And I said, I don't mind Donald Trump because he reminds me that I have a Donald Trump in me. In other words, what's in it for me is part of the way that I live. It's part of my being human. And so there's this contrast between the Donald Trump in us and the hero in us, and that to me is the human dilemma, that we have both of those things. And it's the struggle between those two, which is a personal struggle on which the future of the Earth depends. So we looked at that great landscape painting. Could we walk in awe of the size and power of the universe, humble, grateful, eager to find a place in which we could help? And this struggle with egotism is central to all spiritual traditions. Buddhism, Islam, the holy war, is the war between the Donald Trump and the hero. It's not the war to kill other people. In Taoism, if you go to China, they say, regard your neighbor's gain as your own gain and your neighbor's loss as your own loss. In Christianity, there's the golden rule, do unto others as you would have them do unto you. Love the Lord thy God with all thy heart and with all thy soul and with all thy mind. That's appreciate the world, appreciate everything, and love thy neighbor as thyself. These are great messages. So these people seem to me, all of them, to be delivering a common message. The common message is that, hey, the way you live will control not only your life, but also the future of the planet on which you depend and which depends on you. So we have this capacity to bring this new quality of energy and relationship to planetary systems, to bring planetary consciousness. Might the purpose of human life be to aid and participate in a stage of planetary evolution which is taking place throughout the universe. So what can I do? What can any one of us do? The question we ask. So if we could change our own behavior, we could be an example. We can't preach it, you get hated. Also, we can't preach it because we can't really do it ourselves. But we can try. We can share this challenge of being human. And if one person like that influenced 5 other people in 1 year, it's not much. But maybe 5 other people would try. And in the next year, each of them influences 5 people. You know, it seems like nothing. But after 10 years, it's exponential, and that one person who tried may have influenced 10 million people. 1,000 people like that have influenced the whole world. So, consciousness may be a stage of planetary evolution. If the universe has consciousness, we have the opportunity to become a part of it. If, on the other hand, as some scientists argue, we're the first, we have the opportunity to bring consciousness to the universe. Does the future of the planet depend then on the spiritual evolution of the individual human being? And isn't that a wonderful challenge for all of us? Thank you.